All right, so what we're going to do in this part of the lesson is we are going to learn how to solve for a side when we are given an angle and a side. So like a triangle has three sides, right? And so under normal circumstances, a right triangle, in order to find the measure of the third side, you would need the Pythagorean theorem, okay? But you can only use the Pythagorean theorem if you have two sides. If you only have a measure of one side, you cannot use the Pythagorean theorem. However, if you have the measure of one of the sides and you have one of the angle measures, okay, you can then use a trigonometric function. Any one of the one in particular, you can use a trigonometric function and find the measure of the other side. Because in each one of these trigonometric functions, instead of having three sides present, you only have two sides. So if you have an angle measure and one side, that only leaves you with one more variable, and you can now solve for the second side. So I have a procedure that we're going to work through, and you're going to want to write this down. It's 5 steps that'll help you solve for a side. I'm going to put a comma here. Given an angle and a side. Okay, so the first thing you're going to do in this procedure is you're going to draw a diagram of the problem with a right triangle. Okay, so draw a diagram of the problem. Okay, so we're going to draw a diagram of this problem. It says the hypotenuse of a right triangle is 78. So here we're going to draw a right triangle. There's a right triangle. It has a hypotenuse of 78. And then it says, how long is the side that is adjacent to the angle of the triangle that measures 71 degrees? So it's saying that one of the angles of the triangle measures 71 degrees. Let's make it this one right here. We'll say that that's 71 degrees. And it's saying, how long is the side that is adjacent to that angle? Well, here's the side that's adjacent. So we're going to put over here ADJ for adjacent, okay? We could also just call it X if we want to, or Y, whatever you want to call it, okay? But we know this angle measure. We know that the hypotenuse is 78, and we want to know what is the length of the adjacent side, okay? All right, so the second thing you're going to do is you're going to identify the given angle, the given side, and the unknown side. Identify given angle. Okay, so in this case, we're going to call it theta. Theta is 71 degrees. Okay, there it is. The given side. All right, given side in this case is the hypotenuse, which is given as a length of 78, and the unknown side. That's what you're solving for, the unknown. In this case, the unknown side is the adjacent side. Okay? So then step 3 is identify whether the two sides are, well, we already did that. Okay, let's just skip that. So identify the given angle, given side, and unknown side. Okay? And the sides we're identifying as opposite, comma, adjacent, comma, or hypotenuse. That's what we want to know. We want to know whether these sides are hypotenuse or adjacent or opposite, and we want to know how long the given one is. So then step 3 is going to be select sine, cosine, or tangent. So here's the interesting thing. Any one of the combinations of hypotenuse, adjacent, or opposite will be covered by sine, cosine, and tangent. We really don't have to use cotangent, secant, or cosecant. Can we use cotangent, secant, or cosecant? Yes, but here's the interesting thing. We're going to use a calculator. And most calculators only have a button for sine. See, look here. Sine, cosine, and tangent. They don't have a button for secant, cosecant, or cotangent. So here's another calculator. We've got sine, cosine, and tangent. We do not have secant, cosecant, and cotangent. And therefore, we typically use sine, cosine, or tangent. So select sine, cosine, or tangent based on what you know from step 2. Select sine, cosine, or tangent based on the two sides involved. So here's what I mean by that. In this problem, we're dealing with hypotenuse and adjacent. Well, which of these three, sine, cosine, or tangent, which one deals with hypotenuse and adjacent? Well, it's cosine. See, we got 8 adjacent over hypotenuse. Sine does not include adjacent, and tangent does not include hypotenuse. Therefore, we can't use sine or tangent. We're going to use cosine, okay? And then step 4, so here we're going to say we're going to use cosine, okay? Cosine of theta. All right, so then step 4 is set up a ratio, a ratio equation and solve using a calculator. Here's what I mean. So set up a ratio equation and solve using a calculator. Now, let's set up our ratio equation first. So we're going to take cosine equals adjacent over hypotenuse. But instead of writing cosine of theta, we're going to write cosine of 71 degrees because that's what theta is. So we're going to write cosine of 71 degrees equals adjacent over hypotenuse. We don't know adjacent. We're trying to solve for adjacent. So we're just going to write a dj over hypotenuse, but we're not going to write hypotenuse down here. We're going to write 78 because we know 78. And now what we're going to do is we are going to solve for the adjacent side. We're solving for the unknown side. So now what you could do is instead of putting adjacent in here, if you're the kind of person who just needs to see the letter X or some other, or Y or something else, you could put an X here, and X represents the adjacent side. So now to solve for X, what we want to do is multiply both sides by 78. Over here, multiply by 78. And so cancel over here. Now what we have is X is equal to 78 times cosine of 71 degrees. Okay, well, how are we going to get cosine of 71 degrees? Well, we're going to grab a calculator. And you can use this one or your own, okay? But here's the key. You need to make sure that you set the mode of the calculator in degrees before you solve this. Now, these calculators usually start out in degrees, but these calculators usually start out in radians. So if I want to use this calculator, let me show you what I have to do. I'll turn on the calculator, and I got to go to mode right here. I'm going to hit mode, and then do you see here where it says radian? It is in radian mode. I need it in degree mode. I need to go over to degree and press enter. Now it's in degree mode. Then I can hit second mode, and that'll quit out, and now the calculator is in degree mode. For these calculators, you see the DEG at the bottom there? That means degree. Now I can change the mode by hitting this button that says DRG. If I press that, it shows degree, radian, and grades. I'm going to go over to, or if I was in radian mode, I could go over to degrees and hit enter, and then it would say degrees. So you want to make sure that you are in degree mode. And now what I'm going to do is I just got to key in 78 times cosine of 71. And so I'm going to key in 78 times. Now here's our buttons right here. Sine, cosine, tangent. I'm going to hit cosine 71. I do not have to enter the degree symbol. I can just put cosine of 71. Press enter. And it says 25 point, I'm going to go to 2 decimal places, 25.39. And so the length of X, so X is equal to, or the adjacent side is equal to 25.39, okay? 25.39. Now with that, I could now use the Pythagorean theorem and find the length of the opposite side, but the question is not asking me to do that, so I'm not going to. Okay. All right, let's work on a couple of real life examples to see, just to get some practice doing this. Okay, so here's a word problem. It says a tree grows up perpendicular to the flat ground. A man is standing 30 feet from the base of the tree and looks at the top of the tree at a 42-degree angle of elevation. How tall is the tree? All right, so the first thing we're going to do is we're going to draw a diagram of the problem. We have a tree, right? A tree that is growing up perpendicular to the flat ground around it, okay? So right angle here. Tree is growing up. A man is standing 30 feet away. Okay, so here's the man. And it doesn't matter, I know what you're thinking. You're thinking, well, the man, how tall is the man? Look, just think right here, okay? Just think the corner, okay? The man's height is going to be negligible. He is looking up at the top of the tree, right, at a 42-degree angle of elevation, okay? And we want to know how tall is the tree. So the basic idea here is that we have a right triangle, we have a 42-degree angle, right? We have one of the legs is 30 feet, and it's asking, it says identify the given angle, 42 degrees, the given side, 30, and the unknown side. Well, what is the unknown side? The unknown side is the distance from here up to here. That's the height of the tree, right? Well, that's the other side. It's not the hypotenuse, and it is the side that is across from the angle. Therefore, we're trying to find the opposite side. And what we're given here is the adjacent side, okay? Now, so it says identify given angle, given side, and the unknown side. We're given an opposite and an adjacent and an angle. And therefore, it says select sine, cosine, or tangent based on the two sides involved. Well, we're dealing with opposite and adjacent. Therefore, which trig function are we going to deal with? Which of these three includes opposite and adjacent? Here it is, tangent, opposite and adjacent. So we know that this is going to be a tangent problem. Now we're going to set up a ratio equation. So it's going to be tangent. It's always the trig function. Oops, there's supposed to be an n in there. The trig function, so tan, and then in parentheses is whatever angle measure you were given. 42 degrees. So tangent of 42 degrees is equal to, well, the ratio is opposite over adjacent. Well, in this case, we don't know opposite. So we'll just write OPP there. Opposite over adjacent in this case is 30 feet. And now we're just going to solve algebraically. So we're going to cancel the 30. So multiply by 30 on both sides. Cancel. And opposite is equal to 30 times tangent of 42. So I'll grab a calculator. And I'll do 30 times tangent of 42. I'm going to make sure I'm in degree mode in the calculator. And I get 27.01. So the opposite side is 27.01. Therefore, the tree is 27.01 feet tall. Okay, 27.01 feet tall. Let's try another example. All right, so in this word problem, we're going to try and follow the exact same procedure. And this, we have a couple ships that are traveling on the water relative to a lighthouse. It says that ship A is traveling west toward a lighthouse. Okay, so we've got a lighthouse here. Okay, I'm not very good at drawing lighthouses, but there we go. It's beaming light. Maybe it's on some land. There's a lighthouse. Ship A is traveling west toward the lighthouse. Okay, so traveling that way, but you know, here it is. Here's ship A. Okay, that's not a very good drawing of a ship, but that's okay. I'm not an artist. Ship B is traveling north away from the lighthouse. So that's north. Here's ship B traveling north. Again, I'm not very good at drawing ships, but there's a ship. There we go. Maybe I'll add that to this one over here. Okay. traveling north away from the lighthouse. Now, because this ship is traveling directly west and this ship is traveling directly north, their distances from the lighthouse are at a right angle. Okay, so we've got a right triangle. It says that at one moment, ship A's view of ship B is a 67-degree deviation to the right of its heading. So here's its heading to the right this way, 67 degrees this way. So ship A to ship B, this is 67 degrees. Okay. Now, it may not look like 67 degrees because of the way I'm drawing it, but it doesn't matter what it looks like. What matters is the word problem says it's 67 degrees. Okay. 67-degree deviation to the right of its heading, and ship A is 1.7 miles from the lighthouse. That means that the distance from ship A to the lighthouse is 1.7 miles. Okay. Now it says, how far, and this should be a question mark, it says, how far is ship B, here's ship B, I should have put a B there. How far is ship B from ship A? Well, the distance between ship A and ship B is this straight line right here. That's a hypotenuse, right? So we are dealing with a hypotenuse, and then we're also dealing with, well, what is this side, this 1.7, which is what we're given, relative to the angle measure of 67 degrees. Well, this 1.7 is adjacent to the 67 degrees. So we have an adjacent and we have a hypotenuse is what we're solving for, right? So HYP, okay? So we're going to go over here. It says draw a diagram, identify the given angle, given side, and the unknown side. We're given we're given an adjacent. We're trying to find a hypotenuse. Relationship between adjacent and hypotenuse is cosine. So it says select sine, cosine, or tangent based on the two sides involved. We're going to select cosine. Then it says set up a ratio equation and solve using a calculator. Okay, so all I'm writing is exactly what you see here. Cosine of theta equals adjacent over hypotenuse. But I'm going to replace theta with an angle measure, and I'm going to replace adjacent with the distance that they gave me. So I'm just writing the formula for cosine. So cosine of 67 degrees is equal to adjacent over hypotenuse. Well, in this case, adjacent is 1.7 miles over hypotenuse, HYP, here. And so now we're going to solve for cosine. Okay, so we're going to multiply by hypotenuse on both sides. Multiply by hypotenuse. Now you may think that doesn't really, we don't really get anywhere with that. Yes, we do. Because we're solving for hypotenuse, it's hard to solve for a variable that's in a denominator. So we need to, for now, we need to put it over here. So now we have hypotenuse times cosine of 67 degrees is equal to 1.7 miles. Now we can divide by cosine of 67 degrees on both sides. Cosine of 67 degrees. On the left side, that's going to cancel, and we have hypotenuse is equal to 1.7 divided by cosine of 67 degrees. So let me grab a calculator here. And I'm going to do 1.7 divided by cosine of 67 degrees, and I'm in degree mode, and that's going to give me 4.35. 4.35. What? Well, it's miles, because we're doing this whole thing in miles, because we were told 1.7 miles. So the distance between ship A and ship B is 4.35 miles. Okay? All right, let's do one more example. All right, our last example here. You're standing, or you are at the top of a 100-foot observation tower looking down at your friend standing on the ground below. Okay, so here's the observation tower, okay, and here's you up here, yay, okay, and your friend is down here on the ground, okay, and so presumably the observation tower is built at a 90-degree angle from the ground, okay. Your friend is standing somewhere down below. Your friend is standing over here, okay. There's your friend, yay, okay. And your friend has a cell phone and you have a cell phone, right? Your friend texts you that you are at a 28-degree angle of elevation from them. So they've got a little device down there that measures the angle of elevation, and they tell you that, hey, but from me up to you is a 28-degree angle of elevation. Okay? The question is, how far is your friend from you? You're here, here's your friend. The distance between you and your friend, well, that is this line right here, right? And so that is the hypotenuse. And we know that this right here is the height of the tower, which is 100 feet. So we drew a diagram. We're identifying the given angle, which is 28 degrees. The given side is the opposite side from the 28 degrees. It's all the way over here. So the opposite is 100. So I'll put that here. Opposite equals 100 feet. Okay? And the unknown side, well, we know that the unknown side is the distance between you and your friend, and that's the hypotenuse. So we are looking for, step 3, select sine, cosine, or tangent based on the two sides involved, where we're dealing with an opposite and a hypotenuse, right? Well, opposite and hypotenuse deals with sine, so we're going to choose sine. And so for step 4, we're going to set up that sine function, or equation, sine of theta, but instead of theta, we're going to put in the angle measure, which is 28 degrees. So sine of 28 degrees is equal to opposite, which in this case is 100, over hypotenuse. And now we just want to solve for hypotenuse. So we're going to multiply both sides by hypotenuse. This is just like we did in the last example. We're going to have a couple steps here. Hypotenuse. That's going to cancel the hypotenuse here. Then we're going to divide by sine of 28 degrees on both sides. Divide by sine of 28 degrees. Okay, that's going to cancel sine of 28 degrees here and leave hypotenuse equals 100 divided by sine of 28 degrees, which we can just enter into a calculator. So grab scientific, or let's grab the graphing calculator this time. Like I said, I put it's in degree mode. All right, and so I'm going to key in 100 divided by sine of 28, close parenthesis, press enter, and I get 213 equals 213. So your friend is 213 feet away from you in this particular situation, okay? And that is how we solve these interesting, quote-unquote, real-life problems when we have the length of one side, but we also have the measure of one of the acute angles in a right triangle, okay? And so I'm going to give you several problems that look like this so that you can really sharpen your skills and be able to identify whether you're using sine, cosine, or tangent, okay? I only have one more thing to show you in this particular lesson.